Today we will understand something about the fundamental forces that are acting in the universe. There are basically four fundamental forces. So if we go with the fundamental forces, there are basically four fundamental forces. One that is very well known, gravitational. Second is also very well known with weak nuclear force. Third is electromagnetic force. And fourth one, that is also known as strong nuclear force. So first of all we will learn about these forces and we will compare them, that how strong they are. So first we will talk about the first one, that is gravitational force. So first of all I would like to write now this force is the weakest force in the universe. So this is the weakest force. It acts on each and every particle. Second thing, does not require any medium. One more thing that we can put over here, that is it is two body force. Now let's see what is this two body force. This is a new concept, that at a time, what does this mean? So that at a time we can calculate force between two particles only. So what does this mean? At a time, if we want to find out the force, we can calculate the force between two particles only, and then we can have to sum up all the forces acting between the different particles. Like suppose I have one coordinate system, say x and y or whatever. Here I have some particles. This particle is with mass 1, this particle is with mass 2 m2, say another particle with mass m3 and another particle that is with mass m. Now suppose I want to find out the force acting on this particle m due to m1, m2 and m3. So what I need to do here, first of all we will say that the distance of f1 for the coordinate system is say r1. In a similar way, the distance of m2 from the coordinate is r2. Similarly, for m3 it is r3, and for m say it is r. Now we also have some distance between the particles. Say the distance between m1 and m is r1 dash. Then I will take distance between 2 and m, it is suppose r2 dash. Then suppose I am taking distance between 3 and m, that is r3 dash. So consider that these three are the distance between these particles. Now I want to find out the force acting on m. So as per as this two body force rule, I can say that the statement of gravitational force is like that each and every particle in the universe act a gravitational force on each other. These gravitational force, say we say it as a Fg. So this gravitational force is directly proportional to the product of their masses, and this gravitational force is inversely proportional to the square of the distance between these two particles. So ultimately we can say that Fg is proportional to m1 m2 over r square. Now here in this case of this r is the distance between these two particles, that is m1 and m2. So suppose we want to find the gravitational force on particles m1 m2 m3 that acting on m, we can simply apply the rule and say that for suppose F1, that is the force acting on the m, we can write it as G. So sorry, one more thing that I have to explain, that here if we remove this proportionality sign, we get one constant that is called, Newton called is a gravitational constant, and it is in written as a capital G. So this is the equation of gravitational force. So here this distance r is actually the distance between two particles. So suppose I want to find the force between 1 and m, I can say that F1, I give it as a name F1, it is equals to G m1 m over r1 dash square. So I have given it name as a r1 dash, so it is r1 dash square. Now this force is similarly for particle 2. Suppose m2 is acting on it, we can say that F2 is equals to G m2 into m over r2 dash square. So on. And suppose for 3 I can say that F3, if we use as a vector sign, each one will follow the direction of the resultant force that we will learn in chapter number 2, 3 and 4 in a detail. So right now we have to just sum up it. So that is M3 into M over R 3 dash square into vector R3. Now what are these directions and all that we will learn in chapter number 4 and 3. So here suppose the resultant force that we need, F resultant, say Fr, is equals to F1, F2 and F3. So this is the method that how we can add up and calculate the total force that acting on any particle due to other particles. So this is a gravitational force and its explanation. Newton stated that each and every particle in the universe acting a gravitational force between each other. This gravitational force is directly proportional to the product of their masses, and it is inversely proportional to the square of the distance in between them that I have explained over here. So he used this formula. When proportionality sign is removed, he give this G as a gravitational constant, and then I have explained you that how we can narrate it. About something about this gravitational acceleration also, that gravitational constant also, we have to understand something, that this G is called the gravitational constant. Its value is 6.67 into 10 to the power minus 11. Its unit is Newton into meter square per kilogram square. So this is the unit of gravitational constant, and this is the value of gravitational constant. Now the interesting fact about this force, and that is it is the weakest force. So now you can understand that this force acts between each and every particle, and still it is the weakest force. Now we can understand that the gravitational force obviously acting between the sun and the earth, and due to that only the earth can revolve around the sun. In the same manner, all the planetary system is following the gravitational law, and they are revolving around the sun, and even though this is the weakest force, so we can understand that how much the stronger portion or the stronger forces will behave. So this is about the gravitational force. Now we will learn for the second force, that is weak nuclear force. So before that we will go with this electromagnetic wave. So I will explain that electromagnetic wave. This force is also universal force, and that is also acting between electric particles or electrically charged particles. So it is acting between charged particles. Second thing that is to be understand, this is the second largest stronger force. That means second largest force. third thing, that it is acting in all the medium. So it also actually does not require any medium, but generally it is acting for a longer distance. So it is a long distance force also. This also is a long distance force. Previous force was also long distance. So that gravitational force was also a long distance force. So we can also add up here, that is long distance force. That we can remember. Now, what are the speciality about this electromagnetic wave and electromagnetic wave which are acting force, that is electromagnetic force? So this is the second largest force, and it is about the force between electrically charged particles like proton and electron. Now we know that one particle is positive and one particle is negative, then that force is always attractive. But if the force between positive particle will be there, or it will between negative particle will be there, then it will be a repulsive force. In spite of that, the gravitational force is always attractive force. It is always attractive. So we remember here, this is always attractive. Gravitational field is always attractive, while electromagnetic force can be attractive as well as it can be repulsive force. So this is about electromagnetic force. Now third force that we will understand about is nuclear force, and nuclear force has a two type. One, that is weak force, and second, that is a strong force. Here one common thing between them is they are short range force. That means generally they are acting in the region of 10 raised to minus 14 meter to 10 raised to minus 15 meter range. This is actually the range of the nucleus. So these forces are acting in nucleus, and therefore they are considered as a nuclear forces. Now first we will understand something about weak force. So we say that weak force is generally acting when the fundamental particles called neutrino are emitted from the nucleus. So this is at the special time which is the part of electroweak force. At the time of radioactivity, when neutrino particles are emitted, or we can say that at the time of beta particle emission, this weak force comes into the picture. So this is very short information about this weak nuclear force that is come into the picture when radioactivity is there. We know something about the radioactivity, that alpha, beta, gamma, all these particles when emitted. So out of these, when beta particle is there, it is linking with it with beta particles, and with them neutrino particles are also emitted, antineutrino, neutrino, all these. So at the time of this phenomena, the electroweak force come into the picture. So this is very short range force. This is emitted, or this force comes into the picture when beta particles are emitted from the nucleus, and with them neutrino, which are also the fundamental particles, are emitted from the nucleus. So this is the force when this phenomena happens. And the last, that is strong force. Now we will see that what is about it, what is this strong force and how it works. So strong force is also the short range force, but it is responsible for the formation of the nucleus. So for any atom we must require nucleus, and nucleus can only be formed if a strong nuclear force is acting between them. So it is of attractive type, but it only comes into the picture when these fundamental particles are required to keep together, comparing them. So the comparison between them is given in a particular manner. Here I will draw a small table, and then I compare between these forces. So first I say the comparison of the power in between them. So if we say that strong force has suppose one value, then the electromagnetic force will have the strength of about 10 raised to minus 2 times. So we can say that the electromagnetic force is about 100th part of strong force. So 1 upon 100 times stronger than the strong force, or we can say that it is a weaker. Now weak force, so weak force is about 10 raised to minus 13 times weak than the strong force, and at the last gravitational force, if we talk about it, it is about 10 to the power minus 38 times weak than the stronger force. So strong force is the strongest, while gravitational force is the weakest. So this is the comparison between them. We can compare one to one also. That means if we compare these two forces, we can say that force of EM upon force of gravity that is comparable in this manner. We can say that is 10 raised to 36 times. So electromagnetic force is about 10 to the power 36 times stronger than the gravitational force. So we can have this type of comparison also. We can also compare like this. We can have comparison, that is comparison between weak force upon gravitational force. So we can say that this is 10 to the power minus 13, this is 10 to the power minus 38. So this is about 10 to the power 25. So weak force is about 10 to the power 25 times stronger than the gravitational force. So these type of comparisons are useful when we are considering some of the examples. Similarly, we can compare between electromagnetic force and weak force. So we can have comparison for these two. And that is F electromagnetic upon F weak. See carefully, 10 raised to minus 2, and here this is 10 raised to minus 13. So I can compare, this is 10 to the power 11. So F electromagnetic force is about 10 to the power 11 times stronger than the weak force. So these are some comparison between these fundamental forces. Here also interesting to know something about the forces and their actions. That one unification theory for the forces is there into the existence, that is in which scientists have tried to unify all the forces together, and they have tried that they try to found in the manner that all the forces are coming from the same sources, that means their emergence are same. So many scientists have tried it, so that is called the unification of forces. For that many scientists have tried. Out of that, Newton has tried to unify terrestrial and celestial domains under a common law of gravitation. So न्यूटन ने ये सबसे पहले ट्राई किया, और उन्होंने भी ग्रेविटेशनल फोर्स के साथ जो टेरेस्ट्रियल एंड सेलेशियल डोमेन्स है, मतलब कि प्लैनेट्स मान लीजिए अर्थ एंड सन के बीच में जो फोर्सेस लग रहे हैं, या डिफरेंट प्लैनेट्स के बीच में जो फोर्सेस एक्सर्ट हो रहे हैं, उन सभी को उसने एक कॉमन लॉ के तहत ग्रेविटेशनल फोर्स के साथ कंबाइन करने का ट्राई किया. सो ही ट्राइड टू कंबाइन ऑल द फोर्सेस टुगेदर विद द ग्रेविटेशनल फोर्स. देन Oersted and Faraday, they have tried to unify that electric and magnetic phenomena together. They have also made many experimental discoveries, and they have shown that electric and magnetic phenomena are general inseparable. So they are generally comes into the picture together. So they are the second pair of the scientists. We can say that not they together, but they are individually tried. So one is Oersted, second is Faraday, so we very well known name. Faraday has also tried it. Then Maxwell tried to unified electromagnetism and optics, and he also tried the discovery of the light is an electromagnetic wave. So he fundamentally proved that the Maxwell is another very well known. जिसने ऑप्टिक्स और इलेक्ट्रोमैग्नेटिक वेव को एक साथ रखा. So the electromagnetism and optics are the common emergence, and they have shown it with the electromagnetic wave. Einstein also attempted to unify gravity and electromagnetism, but could not succeed in this venture. So these are some of the scientists who had tried their work to get some different unification work. Out of that, the newly work was done regarding the weak nuclear force and with the electromagnetic force. So they have combined it and give a name as a electroweak interaction, electroweak force, which is now the unification between the electromagnetic force and weak nuclear force. So there are many scientists are continuously trying to unify them and try to get the common emergence of the forces.